Everywhere from construction jobs to rock concerts, loud noise carries risk of permanent damage to your hearing. But a new study published this week in the journal PNAS has found a chemical trick that might help block the harmful effects of noise on our ears. They developed a drug-based procedure that actually prevented hearing loss in mice. The secret is targeting a key stage in the journey of audio information from the ear to the brain. So sound is picked up by the hair cells in our ears and then delivered to nerve cells which carry the information to our brains. This drug works at the junction, or synapse, between the hair cells and the nerve cells. When a hair cell picks up a sound, it releases a chemical called glutamate, which is then received by special receptors on the surface of nerve cells. But if the sound is very loud or sustained for a long time, the hair cells can produce too much of a good thing. In those cases, a deluge of glutamate is transmitted, and this overexposure can cause damage at the junction between the hair cells and the nerve cells. That damage is known as synaptopathy, and it's one common type of hearing loss. Previous research has found that this damage might be related to the flow of ions, especially calcium. Excess calcium has been implicated in helping along the toxicity that results from too much glutamate signaling. But not all of these receptors actually let much calcium in. It comes down to whether or not they have a protein called GluA2. Each glutamate receptor is made up of a handful of proteins. GluA2 is one of these, but not all receptors have it. It seems that receptors without GluA2 are much more permeable to calcium flow, and that makes them vulnerable to the harmful chemical effects of loud noises. For the time being, we don't have any way of repairing this noise-induced damage. It means permanent hearing loss. So these researchers wondered if they could instead stop it from happening in the first place. So they surgically introduced a drug called IEM1460 into the inner ears of mice. The drug blocked the function of the nerve receptors lacking GluA2. The result was no damage to synapses and no hearing loss in the mice. The technique has been referred to as chemical earmuffs, but since the drug only blocks some of the sound receptors in the ear, the mice's brains still responded to sound normally, suggesting they could still hear just fine. If this idea could be adapted for humans, it has a ton of potential for preventing hearing damage. Imagine being able to take a pill before going to a concert. All the rock, none of the hearing loss. Or before going to a job like construction or manufacturing where hearing loss can be a daily risk. But remember, this was only one study in mice, and the researchers had to inject the drug directly into their inner ears. It's got a long way to go before it's ready for use in people. But while those scientists are hoping to help people keep their hearing, another group in Antarctica has been seeing things no one's ever seen before. They've developed and deployed an underwater robot to take a peek underneath a glacier. It's known as Thwaites Glacier. It covers an area about the size of the state of Florida, and its melting accounts for about 4% of global sea level rise. Most of the glacier is part of Antarctica's continental ice, but at its end, it flows out to sea and gives rise to a floating ice shelf. The amount of ice flowing through this region of Antarctica has nearly doubled in the last 30 years. It's one of the most rapidly changing regions of the frozen continent, and this has a huge impact on our oceans. All of this makes Thwaites kind of a big deal for scientists seeking to understand our changing climate. In particular, this team of scientists, part of the International Thwaites Glacier Collaboration, wanted to get a look underneath the glacier at an area called the grounding zone. The grounding zone is the area where the glacier transitions from sitting on land to floating on water. It's also a prime region of glacial change, where the ice can be eroded away by warming ocean waters. So understanding what's going on in the grounding zone can give us a lot of information about the future of this very important hunk of ice and its impact on our seas. But the grounding zone is a treacherous, hard-to-reach place, so the team made a robot to venture where they could not. It's called Icefin. It's a submersible robot designed to collect data in the grounding zone. From atop the glacier, the team drilled roughly 700 meters down to the seawater below and lowered Icefin through. Once it was down there, the robot took a trip of over a kilometer to measure, image, and map the grounding zone. The success of Icefin opens up a whole new way for researchers to measure and monitor rapidly changing glaciers like Thwaites. Another Icefin robot has already been deployed under the Cam ice stream, a river of ice on Antarctica's Ross ice shelf. As our world continues to change in dramatic ways, science like this will help us keep an eye on the most vulnerable parts of the globe. Thanks for watching this episode of SciShow, which is produced by Complexly. If you want to keep imagining the world complexly with us, check out our channel Animal Wonders, hosted by Jesse Knudsen Castaneda. Animal Wonders is an animal rescue and education facility that cares for close to 100 exotic animals and non-releasable wildlife. They're an educational outreach facility based here in Montana, and they rescue displaced exotic animals and allow them to become ambassadors for their species. Every week on the Animal Wonders YouTube channel, Jesse features different animals and shares what it's like to keep them healthy and happy. Recently, Jesse and the Animal Wonders team took in Tigli, the Arctic fox. If you'd like to learn about Tigli's story and find out how he's getting along with the other foxes at Animal Wonders, there's a link in the description to a video all about that.